So let's have a look at complex number in different quadrants. I'm going to do this example. Write the complex number z equal to 4 minus 3i in modulus, argument, or polar form. So let's see if when we draw this, what it looks like. So it is a positive 4 on the x-axis, the real part of z, and then it's negative 3 on the y-axis, the imaginary part. So in other words, z is now in the fourth quadrant. So let's see how that influences my values of theta and r. So now theta is that angle which we can either take from the positive x-axis in this direction with a negative sign, or we take it from the x-axis into the positive direction with a positive sign. Right, we'll see how that works. So in order to get r, it is going to be x squared, which is 4 squared, plus negative 3 squared. So r then is the square root of 25, which is 5. Right, so that's r. Now let's have a look at theta. Remember that this distance here is then negative. The distance is positive 3, but my value here is 3. So to get theta, I can choose any trigonometric function or ratio. I'm going to use sine of theta, which is the opposite over adjacent, over hypotenuse, opposite over hypotenuse. So therefore, it's going to be negative 3 over 5. And from this, I get that theta is then, in other words, negative 36.87 degrees. Right? So this is the negative part of the angle, if I want to write it in a negative notation. But I can also just add 360 to that, and then I'll get that theta is 323.13 degrees. So to finalize this, z is then 5 cos 323.13 degrees plus I sine of 323.13 degrees. Remember to answer the question, and that is z in polar form.